morning everyone. I am Ganga Devi from SFR College. Through this tutorial we are going to see what is the distance vector routing algorithm. So we all know routing is the major part in network layer. It is a process that is carried out by network layer to deliver the packets from one network to another network by using the IP packet address. Okay, there are two types of routings available. One is the static routing and another one is the dynamic routing. In static routing, the routing table is the major part that plays the vital role in the routing. We all know that routing table is getting created manually by the network administrator in static routing. But in dynamic routing, the router itself is going to exchange all the information with its neighbors and dynamically update their routing table according to the data they are receiving at that time. Okay. So, today we are going to see the distance vector routing algorithm, which is the dynamic routing algorithm concept. So, here each router is computing the distance between itself and its neighbors, okay, immediate neighbors. So, after computing the routing table, they are distance vector values, they are updating the routing table depending upon the knowledge they are earning from the neighbors. So, they have to, for doing these things, they have to transmit the details they are obtained from their neighbors to all the neighbors, and they have to update the routing table periodically. Okay. So, since they are using this approach, this is the Bellman-Ford approach. So, this algorithm is also called as the Bellman-Ford algorithm. So, it should be carried out at a regular interval of time. So, the steps involved are, the first step is the router have to transmit the distance vector to each of its neighbors. At the second step, the other routers, the immediate neighbor routers have to receive this vector, distance vectors, and they have to save the most recently received distance vectors, and they have to analyze which one is the smallest, and they have to update their distance vector by recalculating the values. Okay. So, let me see an example. So, here I have given a network. So, here there are 4 routers are available, A, B, C and D. Each and every routers are having a unique ID. Apart from that, each and every router have to get connected to one and all by using the link cost. Okay. So, here I have provided the link cost also. So, for updating the routing table, we are going to use the formula d of x is equal to minimum of the cost of the source router to the neighbor router and also the cost, the minimum cost of the neighbor. Okay. So, we have to calculate this value. So, let me see an example. So, in the step 1, I am just giving the values for the router 1 only. So, router A only. In the step 1, what we are going to do is, we have to create a router table, right. So, in the router table, it contains the destination data and the distance data and the next hop data. So, the destination is the name of the network that is going to define the final destination for the packet. Okay. So, the distance is the number of hops that the packet have to transfer, and next hop is the the next router where the packet have to be getting delivered. So, here from the example I have derived the router table. You can see that from A to A there is no route, so it should be 0. From A to B the immediate data is 2, link is 2, right. So, from A to C we are not getting any immediate link, so it should be infinity. From A to D there is a link with the cost 1, so it should be 1. Okay. So, this particular routing table after the step 1 should be transferred to all the, that is passed to all the neighbors for further processing. In the step 2, so after getting these values again, so router A have to pass these values at the same time. Router B, router C, router D, everyone will calculate the basic router table and they have to pass its data to the neighbors, right. So, A is receiving data from the neighbors B and D as shown in the middle table. So, from B it is getting the distances as 2037, that is from B to A, B to B, B to C and B to D. From D also it is getting the data from D to A, B, C and D. Okay. So, after receiving this data we are going to recalculate the routing table values, right. So, for routing table values we have to find the minimum of those. So, from A to the destination, right. So from B, that is our neighbor, first neighbor is B. So from A to B the cost value is 2 and 0. So we have to add it. Again for another neighbor is D. From A to B the cost value is 1 and 7. So we have to add 2 and 8, which is smallest, 2 is the smallest. So we have to choose via B. Likewise we have to calculate for A to C and for A to D also. And calculating this we can get that in the first table C value is getting an infinity value, that is there is no direct path from C to somewhere else, right. Here we, after calculating this value, we are getting that from A to C that the minimum path is 5, it is getting updated here, right. So after this the step 2, after this step 2 the routing table is again getting transferred to the neighbors. So at the step 3 again the value is going to be calculated. So here also again the router A is receiving the updated neighbor data, like from B it is again getting some values, from D it is again getting some values. After calculating whether the updated routing table is going to give us some minimum routing data or not, they have to decide, but here there is no change. So that is all, okay. So at the end like this, the router A is calculating some data, router B is calculating some routing table, and C and D. All the updated routing tables are provided in this slide, you can see that. So in router A the link AB and AD is the only paths they are using in A, right. For B they are using only BA and BC link, and for C they are using only the link C to B, and for D they are using only the link D to A, right. So the edges BD and CD are never used in this particular algorithm. So as I told you, the routers are creating their route dynamically with only the data they are knowing, right. So on knowing sharing their knowledge, they are finding the optimum path without including the highest cost paths in this routing, right. Okay. So finally this algorithm is also having some disadvantages. So it is slower and it's maybe lead to count to infinity problem also. It should periodically compound update should be periodically happen, right. So without any network changes also it should do that periodically, compulsorily. That is why it may lead to bandwidth problem also. And finally for larger networks, if you are going to calculate this distance vector routing algorithm, means for larger networks it may lead to some congestion problems. Otherwise this algorithm is very best for routing, okay. So thank you for watching.